This is lesson 831A. We're going to be dividing a polynomial using polynomial long division. And so today's objective, we're going to divide a polynomial. So far, whenever we had a polynomial, it was already factored. And you saw it in forms like x minus 2 squared times x plus 5 to the fourth times x minus 3. And that's when you guys went through and you found the y-intercept and you found the zeros with its multiplicity, etc., right? And the end behavior. And that's how we were able to graft a polynomial. Now, this is in factored form. It's completely factored. But what if I asked you, okay, here is a non-factored polynomial. How do I find the zeros of that? Now, we already know how to do some of it. I mean, you set it equal to 0, right? But then it's still, how do we factor that? And so we don't have any factoring techniques to factor a polynomial when it's bigger than 2. Like, we know how to factor a quadratic equation, but a cubic, we don't really have the tools yet. We can graph it, right? So we know that we can graph it and we can look at where it crosses the x-axis, and that can help us out. But that's still, how do you find that? So we need to change the way that our brain kind of thinks about division. And so we need to know polynomial division to be able to factor that. And you're probably wondering, well, why do I need to know division to be able to factor a polynomial? Well, let's think of this. If I have the number 10, what are the factors of 10 if I were to factor that? Well, you'd probably say, okay, 2 times 5. Well, some of you probably did 10 divided by 2 is 5, 2 and 5, right? And so we use division as a tool to be able to factor that. And so that's why we need to know how to divide a polynomial, is because that's going to be a tool that we could use to be able to factor our polynomial. And so this is just the definition of polynomial division. I don't need you to get it down, but it just says essentially that if we divide a polynomial, we can actually divide it by another polynomial. And it allows us to write it as factors with some sort of remainder. Now, it is awkward. It is awkward because we're not used to writing it as factors. But through this process, where over the next few lessons, where we're going to be practicing these division techniques, it's going to help us and it's going to make a little bit more sense. So the process of polynomial long division. We need to set up the problem. And if you look at that, you're probably thinking, wait, I think I've seen something like that before, and you're absolutely right. This is just like regular old division, except we're using abstract variables. So you set up the problem, right? You're dividing by this value, so that goes there. You take that, and you put it inside the little half box thing. And what we're going to do is we're going to divide this first term into this first term here. And if that's kind of weird to think about, that's basically what we're doing when I say divide. So I'm dividing that into x cubed. Now when you do that, you're going to get x squared. And we put that on top. Then we distribute this number, or this value here, with both of these values, and we put it under the corresponding value. So for example, x squared times x gives me x cubed. Well, I'm going to put that under the x cubed. X squared times negative 3, I'm going to put that under the x squared because it's x squared. X squared times negative 3 gives me negative 3x squared. Now what we're going to do is we're going to subtract. So if I'm going to subtract, that means that negative does get distributed, which means negative, positive. And so when we go through and we subtract that, can I erase that part there? What ends up happening is the x cubes cancel out, and then 2x squared plus 3x squared gives me 5x squared. Now you're probably wondering now, you're like, okay, this is kind of familiar. And it should feel familiar. We've essentially kind of already did this before, just with numbers. If I said divide 4 into 820, well, the first thing we did is we divided this number into this number. 4 goes into 8 2 times. Then we multiplied. Then we subtracted. And then now you're probably thinking, I got to bring down that 2. Well, guess what? I got to bring down that negative 13. And then we repeat the process again. X goes into 5x squared. So you want to divide that, and that's going to give me 5x. Then we multiply. So 5x squared and negative 15x. Then we subtract. So if that minus distributes, which it's going to do, that will give me a minus 5x squared, and that'll give me a positive 15x. So those will cancel out, and then I'm left with 2x. Bring in the next value. X goes into 2x twice. Distribute the 2, so I get 2x. Distribute the 2, negative 6. Subtract, so then that distributes. And then that cancels out and that cancels out. And so your remainder is going to be 0. And so this is my answer. And if I wanted to write it as it's factored, I can now write it as x squared plus 5x plus 2 times x minus 3. And so that's what this equals. So doing just straight division, it's this. But if I wanted to write this now as a factored form, so this value right here, if I wanted to write that as factored form, I write it like this, which is going to be this value here, and then whatever I divided by goes here. Now you can only write it like in that factored form when the remainder is 0. Okay, so that's really important. So the first thing I did, set up the problem. Then divide the first term into the first term. So I did x into x cubed. Put that value on top. Then I distributed that value with both of those values, and I wrote it under the correct terms. Subtract, so change the signs, and then do your, add straight down, 0, add straight down, and then you just repeat the steps over again. Let's look at another one. So we need to set up the problem. X cubed minus x squared plus 1, negative x to the 5th. Now, if you notice, it is descending, but there are gaps, right? There's no x to the 4th. I need to put a placeholder. And you're going to see this being very prominent. You have to put in placeholders if there are gaps or there are missing spaces. I don't have an x squared either. And then I don't have a constant, so I'm going to put a 0 there. So you just do that, and you're going to see why in a second. Sometimes things don't line up correctly, and you want to make sure that they line up. So divide the first term into the first term. So first term divided into this value here. So write it off to the side if that helps. So that's going to simplify into minus x squared. Then I want to distribute that value and put it under the divisor. So this times this gives me minus x to the 5th. This value times this value gives me a positive x to the 4th. See why I put the placeholder now. I would not have had a spot to put the x to the 4th if I didn't put the placeholder. And so that's why we needed to include it. And then this value times this value gives me minus x squared. Right? It does not go under the x cubed. It goes under the x squared because it's x squared. So now subtract. So then that means that that minus is going to distribute, right? So that goes positive. That is going to go negative, and then that's going to go positive. So then when I add straight down, we get 0. That's going to give me a negative x to the 4th. I can bring that down, so 7x to the 3rd. This gives me positive x squared. I still have that minus x, and I still have the plus 0. So now we repeat. So this value, the first term divided into first term. So minus x to the 4th over x cubed. So that's going to turn into minus x. Now we're going to distribute. So this value times this value gives me minus x to the 4th. Negative x times negative x squared gives me a positive x cubed. Negative x times 1 gives me minus x. Subtract. So that means that this is going to distribute. So that's going to turn into a positive. That'll turn into a negative. And that'll turn into a positive. 0, 8x cubed, because that's a plus 0, so plus x squared. And then the x's cancel out, so plus 0. And I still have that plus 0. So we do it again. X cubed goes into 8x cubed. I get plus 8 times. Distribute. 8 times x cubed is 8x cubed. 8 times negative x squared is negative 8x squared. 8 times 1 is plus 8. So subtract. So I'm going to change the signs. 0, 9x squared, minus 8. Okay, well, this is now my remainder because this value right here can't go into that. So what we're going to say now, so my final answer is going to be negative x squared minus x plus 8 plus, and then we're going to say the 9x squared minus 8, that's my remainder over what we divided by. And so this right here is my answer. So x goes into 3x to the 4th, 3x cubed. Distribute. Subtract. So that means you change the sign. Minus plus. So when these add straight down, you get 0. Negative 10 plus 6x is negative 4x cubed. You can bring down the next term. Now you could bring down all of them if you want. I typically bring down all of them. Some people just like bringing down the next one. The reason why I like bringing down all of them is because if this changes, like let's say this is longer, you're going to need more of these down there. And so I usually just bring them all down just because. So repeat. X goes into minus 4x cubed, negative 4x squared times. Distribute. Subtract. So that negative distributes. So that'll become a positive, and that'll become a negative. So subtracting, that's going to cancel. And then 12x minus 8x is 4x squared. Bring down the next value. Divide. So this value into this value. Now if you need to write it out, write it out. Right? That reduces into 4x. Now distribute. 4x times x gives me 4x squared. 4x times negative 2 gives me minus 8x. Subtract. Distribute the sign. So that'll cancel out. That'll turn into a positive 8. So negative 15 plus 8 is negative 7. Bring down the next value. X goes into negative 7x. Negative 7 times. Distribute. Distribute. Subtract. So that turns into a positive, which is 0. That turns into a negative, so you get negative 8. So this right here is my remainder. And so we're going to say minus 8 over what we divided by. And that's going to be our result. Now I don't need you guys to do this one. I want you guys to try this one on your own, and you can compare with what we have here. So what did we learn today? We talked about polynomial long division, and polynomial long division is basically just like regular division, except we're dividing with polynomials.